In this video we're going to look at geometric sequences. So the first thing we need to know is what a geometric sequence looks like. This pattern of numbers 2, 6, 18, 54, if you look at it you can probably work out what's going on. To get from the 2 to the 6 you times by 3, to get from the 6 to the 18 you times by 3, and to get from the 18 to the 54 you times by 3. So when you get a sequence of numbers and each number is the previous one times by something else, and it's the same rule everywhere, you've got a geometric sequence. So 2, 6, 18, 54 is a geometric sequence where the first term, the first number in the pattern is 2, where what they're multiplied by each time is 3, and it's got 4 terms in the pattern. The first term, we use the letter A to stand for the first term. What we multiply by each time, we call the common ratio, and we use the letter R to denote that. And the number of terms there are in the sequence, we denote with the letter N. And those are the 3 variables, the 3 things that are really important with geometric sequences. The first term, which we denote A, the common ratio, which is your multiplier, which we denote by R, and the number of terms there are in the sequence, which we denote by N. As well as calling the first term A, we could also call it U1. We use U, and 1 is the first term of the sequence. So here I have U1 is 2. Not very surprisingly, U2 stands for the second term, that would be 6. U3 would stand for the third term, and that would be 18. U4 would stand for the fourth term, and that is 54. You can work out the fourth term without knowing the third term, or even the second one, if you know the information about A, R, and N. And we'll just go through that first of all. To start with, the first term, U1 or A, that's 2. What do we do to that term to get the next one? We times it by 3. So that U2, the second term, was the first term, U1, times by 3. And that was 6. What do we do to get the third term? Well, we times the 6 here by 3. So that was the first term, U1, times by 3. Because that's what the second term was. That effectively is my 6. And then that has been times by 3 as well. So that is the first term times by the common ratio squared. And that is my U3. If I look at the fourth term is my original 2 times by a 3 to make it into 6, times by another 3 to make it into 18, times by another 3 to make it into 54. So the fourth term is A, the first term, and then the R is cubed. It's 3 times 3 times 3. It's there 3 times. So you get the fourth term is AR cubed. If I wanted to know the seventh term, I would have to do A times by R to the power of 6. If you look at the pattern, this number here is always 1 less than this one. So the seventh term in this number pattern would be my first term times by my common ratio to the power of 6. Now I haven't worked out what the fifth and the sixth is, but I can go straight there. So on my calculator I can do 2 times by 3 to the power of 6, and I get an answer of 1,458. So I've worked the seventh term out without all of the ones before it. And from here you can see there's a pattern going on, and you can get a general result that the nth term is equal to A times by R to the n minus 1. And that is one of the key formulae in geometric sequences. The nth term is A times by R to the n minus 1. So sticking with the sequence we've got at the moment, where A is 2 and R is 3, if I wanted to know what the 10th term was, the 10th term, which I'll denote as U10, would be A times by R to the 10 minus 1. which is 9. So that would be 2 times by 3 to the power of 9. And again, I could come to my calculator, 2 times by 3 to the power of 9, and I will get my answer, and it would be 39,366. So you can find any term in a number pattern like this quite easily. Apart from working out what the different terms in the sequence are, the other thing you're often asked to do is to add up the sequence. So for example here I may be asked to add up the first 4 terms. Now here I know what they are, I've worked them out, and yes, I can add them up on a calculator. But maybe if I had to do the first 50 terms, I wouldn't want to work out what each of them were and then add them up. I want a quick way of doing it. So some more notation. S with a little n down here stands for the sum of the first n terms. There's another formula you need to know. The sum of the first n terms is equal to a times by 1 minus r to the power of n, all divided by 1 minus r. And that's another formula that you need to learn. So here, as an example, I'll just check that formula works on the first 4 terms. And if I'm doing the sum of the first 4 terms, n is 4, so it'll be S4. It's a, and then 1 minus r to the n over 1 minus r. So on the top, I've got 2, then 3 to the power of 4, 3 times 3 times 3 times 3, that's 81. So in the bracket I have 1 take away 81. And on the bottom, 1 minus 3, that's minus 2. So in the bracket, 1 minus 81 is minus 80. And I'm dividing by minus 2. And if you work that out, you get an answer of 80. And if you do add those 4 numbers up, you do get the 80. The formula does work. And okay, that wasn't very exciting, but if I wanted to work out the sum of the first 12 terms of the same number pattern, where I only know the first 4, I haven't worked the others out, I can still use the formula. It's a 1 minus r to the n over 1 minus r. So the thing that's changed now is I've got 12 up there. Again, I can go for my calculator. I can first of all work out 1 minus 3 to the power of 12. That is a number on there. That needs to be multiplied by 2. And I need to divide it by 1 minus 3, which again is minus 2. So if I divide that by minus 2, I get an answer of 531,440. So I've worked out the sum of the first 12 numbers. I don't even know what they all are, but I do have the sum of them using the formula we've got on the screen at the moment. Looking at another example, if I've got a first term of 4, a common ratio of half, and I'm looking at 8 terms, again I can work out the sum of those 8 terms very quickly. Using the formula we had before, it's a into 1 minus r to the power of n, so that is the r, and the power is applying to that, so I'll write it like that to make it very clear. 1 minus r to the power of n, all over 1 minus r. So if I work this out, I have my 4. Let's do the easy bits first. 1 take away a half, that's a half. A half to the power of 8, if I work up half, quarter, an eighth, 16th, 1 over 32, 1 over 64, 1 over 128, 1 over 256. So a half to the power of 8 is 1 over 256. So that's what I've got. I can put that in a calculator if I wish to. I can do 1 take away the fraction of 1 over 256. That has to be multiplied by 4, and that has to be divided by a half. My answer there is 255 over 32. Now I'd like that as a top-heavy fraction. That's the same as 7 and 31 over 32. Again, I've added up the sequence when I didn't even know what the original numbers were.